Hello my dear brothers and sisters, welcome to a new graph theory problem, which is find center of a star graph, right? So you can say this question is asked by multiple companies, right? So Apple, Microsoft and many more companies. So what is this question is all about? So there is an undirected star graph is given, right? Which consists of n nodes, right? Labeled from 1 to n. So there is a given a undirected star graph. We'll go to the example, but let's read the question. So all the vertices are labeled from 1 to n, right? So a star graph, so they have defined it here. The star graph is a graph where there is one center, right? So one center and exactly n minus 1 edges that are connected to the center node, right? With every other node. That means one center node is there and every other node are connected to that particular center node. So with n minus 1 number of edges. I hope it is making sense. So let's go to this particular example so that you will get clarity, right? So before going to that, so they have represented all the edges into a tuple, so we'll discuss that. So let's understand. So right, so they are given actually the input is going to be like this. So edges, so 1 is connected to 2 and 2 is connected to 3, 1 is connected to 2, you can see 1 is connected to 2 and 2 is connected to 3 and then 4 is connected to 2. So that means these are the edge set which is given in this particular graph, right? And what we are expecting, so that's why you can see it is a star graph, right? So everybody is connected to this particular node, right? So that's why it is star graph, right? So but the question is, what is the center of this particular star graph, right? So that is the question, right? So find the center of the star graph, right? Now the question is, in this example, who is the center of the star graph? So 2 is the center of the star graph. So that is the question is all about. Now how can we solve this particular problem? You can think and for 2 minutes and just put it in the comment box. So what kind of algorithm you are coming of? What is the time complexity you are coming of the algorithm, right? So let me give you an idea, right? So whenever you are going for this kind of problem, so right, so this problem specially, so what you can do, right? So first that, okay, so you can just iterate over all the edges one by one, right? And once you iterate over all the edges one by one, try to find out the degree, right? Or try to find out the degree of a vertex, right? So like you can take an array and maintain, so since there are 1 to n, right? So 1 to n, so you can maintain an array and you can just maintain the degree, right? Suppose like 1 is connected to 2, that means 1 is going to be now 1. So now 2 is going to be now 1, right? Because I got 1, 1. Now 2 is connected to 2, 3, right? So 2 is connected to 3, so 3 is going to be 1, 2 is going to be incremented to 2, right? By this way, if we will keep on visiting the each and every edge and try to find out whose degree is going to be n minus 1, right? Ultimately this array is going to be created and ultimately you will find that, okay, at the end of this particular traversal you will find that, because here 2 will be incremented 1, here 2 will be incremented 1, here 2 will be incremented 1. Since there are 4 vertices, so there will be n minus 1 number of edges obviously, so that's why it is going to be 3. And after that you can iterate and just try to find out which is having the degree 3 for this problem or for this particular example, or else it is going to be n minus 1. So that is the vertex you need to find out. But this is the order of n solution, right? So can you pause this particular video here and think to find out more optimal algorithm, right? So when I say more optimal in terms of time complexity, can you find out a order of 1 time complexity algorithm, right? I hope you have thought of this. Just put it in the comment box whether you are able to solve it using order of 1 time complexity. I would like to see this particular your answer, right? So let me explain also. So this is a star graph, right? So try to understand. So there is only one center and everybody is connected to that center. Do we really need, answer this particular question, do you really need to traverse every vertex, right, in order to find that center? Right? Since it is a star graph, you are already given a star graph, means one vertex is there, everybody is connected. Why do you really need to traverse every edge in order to confirm that, okay, 2 is the vertex, which is the center? Why can't you just traverse any 2, right? What I am trying to say, traverse any 2 edges and try to find out, like suppose you are traversing these 2 edges. You can traverse any 2 edges and whoever is the common vertex associated with these 2 edges, there may be 1000 number of edges, I don't care, but whatever the common vertex between any 2 edges, that means that is going to be common for all as well, right? So that's why you don't need to traverse actually the whole particular edge set, right? So that's how you can solve it also using this particular order of 1 or constant set. Let's do this particular thing so that you will be able to understand so more details, right? So in case you have any queries, you can put it in the comment box. But let me find first two, right? So int age is equal to edges of 0, right? So I am taking only two edges. So what I am trying to do, I will take edge 1, edge 2 arbitrary and try to find out which one is the common one, right? So that's what I am just trying to do, right? So int edge 2 maybe, right? Edge 2 equal to edge of 1, right? So that is what I got the two edges. Now I will try to find out so who is the common vertices among them, and I will declare that one as the center of that particular graph, right? Star graph, right? So I don't need to traverse every vertex one by one, right? So what I will do, I need to write little logic to find out the which one is the common between these two edges, right? So this is maybe edge 1, this is edge 2. So I took this 1, 2 and then 2, 3, right? So I need to just find out which is the common, so which is 2. Once I find that, so then I can simply return that particular thing, right? So what I need to do, so if edge 1 of, edge 1 of 0 equal to edge 2 of 0, that means this one is the 0, 1 is the common one, right? So if that is the case, then what we can do, or else if edge 1 of 0 equal to edge 2 of 1, right? So if the edge 0 is going to be same as the edge 2 0, or else it is going to be edge 2 1, right? That means, so this index, so this is the index, right? It is going to be either this one or this one, then that means it is 1 is the common. But in this case, this condition will satisfy, you will go to the 2 1. But if this is the situation, then what you can do, you can return the edge 1 of 0, right? So immediately you don't need to wait, return edge 1 of 0, right? Okay. So because edge 1 is going to be common in edge 2 of 0 and edge 2 of 1, so that's why you are going to return. If that is not the case, then definitely, so this is a star graph, so I don't need to check for any other condition. Immediately I can return edge 1 of 1, because definitely next other vertex is going to be the center of that particular graph. So let's run this particular thing and see. So there is a compilation error, you can see, because this is going to be edges, not edge, because that variable is edges. So let's see if, okay, so this is accepted now. So let's try to submit and see if everything is working fine or if there is any issues. So let me submit this particular thing. Let me, 1 second, let me submit. Hopefully everything should work fine. So I hope it is making sense. If you have any questions related to this, so just put it in the comment box. The time complexity is order of 1. Yeah, it got accepted in a few seconds ago, you can see. So we are good for this particular problem. So we'll meet in the next class with a new problem. Thank you for watching and bye, take care, see you in next class.